Okay, here we go. I got to be able to convert back and forth between radians and degrees. I'm going to go pretty quick because what I found out last year was that the observation from this was that going into it, they didn't feel like they remembered much about trig. And they found that with a quick, about a day and a half review, they felt like they really remembered a lot. So I put this review together. This is basically from the final exam just about. And it should go pretty well. We don't have to know everything from trig, but we got to know some of this basic stuff. So do you remember how to convert to radians? Pi over 180. So we're going to take theta, and we're going to multiply it by pi over 180. So what you really do is you reduce the angle over 180. And so 75 over 180, if you reduce it as a fraction on your calculator, you can divide it up into sometimes multiples of 15 if you want. For example, 15 goes into 80 12 times. 15 goes to 75 5. So this is going to be 5 pi over 12. 60 goes in 183 times, right? How many times does it go into 300? 5. Uh, 120 goes in. Let's see. So 60 goes in 120 twice. 60 goes into 183 times. If you were to multiply this, you would end up with negative 2 pi over 3. If you remember some of the basics, we said that pi over 6 is 30. Pi over 4 is 75. Whoop, it's 45. And pi over 3 is equal to 60 degrees. Pi over 2 is 90 degrees. I have that whole graphic organizer for you. It shows right on front all the values of pi. You have the table as well as the unit circle, also referred to as the circle of life, right? So, we love it. And then what if we were to do something like 129.32? What would you do there? Yeah, you just got to 129.32 pi over 180. And so you just have to take 129.32 and divide by 180 and multiply by pi. What do you get? 129.32 times 3.14 divided by 180. 2.256. So radians can be expressed in terms of pi. They can be expressed as a decimal. Okay. Question for you. Pi radians is the same as how many degrees? Pi is the same as 180. So 3.14 radians is the same as 180. That conversion back and forth. We quizzed on this. You guys did very well. See if you can do part 2 on your own. We went forward. See if you can go backwards. Now what you're going to do is take theta and multiply it by 180 and divide it by pi. So that's how you go backwards. See if you can do the conversion quick. Alright, so 3 pi over 4, what'd you get? 135. 13 pi over 10. 13 pi over 4, negative. Ooh. How about 2.73? Is that going to be greater than 180 degrees or less than 180 degrees? Is it going to be greater than 90 degrees or less than 90 degrees? Greater than. Yep, you're falling right in there. So what'd you get? What was it? 156? Any questions? .73 times 180 divided by pi. Just like Larry said. Alright. Let's try something more interesting, okay? Find all 6 trig functions given secant of theta is equal to 2 tangent is less than 0. Oh boy. This is where really some of the work helps you out. Okay. You want to find all 6 trig functions. So I'm going to list all of them: sine, cosine, tangent, cosecant, secant, cotangent. Which one of these do you know already? Secant theta is. So cosine is. I know tangent is less than 0, so that means tangent is negative and cotangent is negative. I have to find the quadrants where I'm working in. Where is theta located? As you look at your quadrants, I have to remember where things are positive and where they're negative. If you remember, all of them are positive here. Sine is positive here, tangent's positive here, and cosine is positive here. All seniors take Calc plus 1 junior. So that's what you have. So if cosine's positive and tangent is negative, which quadrant are you working in? Cosine is positive here and here. So which one is it? It's 4, because tangent is positive up here as well, but you know tangent is negative. So we're working in quadrant 4. If you're working in quadrant 4, you know tangent is negative and sine is negative. Negative, 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 negative. If I know secant is 2, how can I find another value? Got a couple options. Now I'm going to encourage you to go here because, although this may not be the direct way we did it last year, this is how you would do it in moving forward in calculus. We have a couple formulas. Cosine squared theta plus sine squared of theta is equal to what? 1. Gotta remember this. That's the most important one. So I have to. If I divide through by cosine, what's cosine squared divided by cosine squared? 1. What's sine squared over cosine squared? Tangent squared. What's 1 divided by cosine squared? Secant squared of theta. Let's take our original function, and instead of dividing through by cosine squared, let's divide by sine squared. What do you think cosine squared divided by sine squared is? Cotangent. What's sine squared divided by sine squared? 1. And what's 1 divided by sine squared? Hey guys, I have all those formulas listed for you. In fact, they're right on the front page, aren't they? Okay, they're all right there. The reason why I showed you that is I was able to write them down without having to look at anything, and I start with this. This is just Pythagorean Theorem in the unit circle. A squared plus b squared is c squared, where the radius is always 1. And from that you can derive the other formulas. Which one of these do I want to use? You could. I really like the second one because it's got the 2. You could use the first or the second, whichever one you want. I'm going to use the second one. I'll set up the formula. 1 plus tangent squared of theta is equal to, what is secant squared? 4, yep. So, you've got tangent squared is equal to 3. So what's tangent equal to? Square root of 3, positive or negative. We've already decided that. We got negative root of 3. So what is cotangent? Negative 1 over the square root of 3. That's for disability being deaf. Oh, dumb. Your disability is being dumb. There you go. Right, so you multiply top and bottom by the square root of 3, and you get negative root of 3 over 3. Very good. Yep. So how do you find sine and cosecant? What's that? Yeah, to which one? I got an easier way to find sine and cosine, or sine. I know a formula as well. You remember this one? Sine of theta over cosine of theta is equal to tangent of theta. That's on your sheet as well. In fact, if you flip it over to this side, I have this list of formulas, which everybody seems to really like. Okay, everybody really likes that page. People do not generally like this page very much, but that one is a nice summary of just about every trig formula you would ever need. So, this works out pretty easy. If I want to use this formula, I've got sine of theta divided by 1/2 is equal to negative root of 3. How do you solve for that? So it's, yeah, you divide by 2 because dividing by 1/2 is the same as multiplying by 2. How do you get rid of multiplying by 2? You divide by 2. So you got negative root of 3 over 2. And then you would have to do, then you have to take the reciprocal, and you get negative 2 over the root of 3, which, as Hannah said, you cannot have root of 3 on the bottom. That's equal to negative 2 roots of 3 over 3. So those are your 6. So you got to be able to work between sine and cosine. You got to be able to use the formulas that you were given. I want you guys to try number 5. Okay, let's check it out. Here's what I see. Tangent is negative. So here's how I do it. I don't necessarily look directly at it. I quick draw a graph, and I see tangent is negative and secant is negative. Well, tangent is negative in these two. I know that because it's positive there and there. Secant is negative here and here. So I am working in this quadrant because that's where both of them have a common situation. So I know I'm working in the second quadrant. So that's how you figure that out. Once you're in the second quadrant, we set it up. Sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, cotangent of theta. As we set it up, you know that tangent theta is negative square root of 2. That means cotangent, you should come up with negative root of 2 over 2. Is that what you got? Okay, I would choose to use 1 plus tangent squared of theta is equal to secant squared. So, if you square negative root of 2, you get positive 2. So 3 equals secant squared of theta. Square root, and you get exactly. Now, because we're in the second quadrant, we know that sine is positive and cosecant is positive, whereas cosine and secant are both negative. So this is going to be the negative root of 3. Take the reciprocal, negative root of 3 over 3 when you simplify. And then Kaylee chose to do this. This is a good idea. You have sine of theta over cosine of theta equals tangent of theta. So that means that you have sine of theta over negative root of 3 over 3 is equal to negative root of 2. Now, as we do that, you might want to rewrite it. Instead of dividing by negative root of 3 over 3, that's multiplying by 3 over negative root of 3, right? How do you get rid of that? Multiply by the reciprocal. If you multiply by the reciprocal, you get negative root of 6 over 3. What positive, excuse me. And that's the result that we want. If you take the reciprocal of that, I don't know, what do you get? Okay. Three roots of 6 over 6, which is root of 6 over 2. Sounds Sounds good. So the reason why I showed you these problems is you're not going to do these problems in calculus. You won't do those type of problems in calculus. But you're forced to think about positive and negative, and you're forced to relate sine and cosine and tangent together. That's important. Okay? So, says solve the triangle. I'll do one, you do the other. I draw the triangle. C is always going to be the right angle. It doesn't matter where you put the other two as long as you put the 20 on the A. So what I have here is I'm going to label my sides. Well, first I'll just set it all up. A, B, C, and little a, little b, and little c. Which of these do I already know? A is 20. C is 90. That means that B is 70. Small a is 3. So now we need to find B and C. Which one would you like to find first? B. All right. If we're going to find B, which do we use? Sine, cosine, or tangent? Tangent, why? Opposite and adjacent. This is the hypotenuse. So remember your SOHCAHTOA rules. We put them into effect. We set it up. The tangent of your angle, 20 degrees, is equal to 3 over B. Now when you solve this, you have to make sure that your calculator is working in radians. So, or I'm sorry, degrees. Because you're working in degrees now. So for those of you who might take the ACT again, this is a good practice for you to see this trigonometry again. Because there's a decent amount of trig on there. So, as we multiply, we get 3 equals 0.3639 times B. And we take 3 and we divide it by that result, you get 8.24. How could you find the other side? You could just use a squared plus b squared is c squared, or you could set up another trig function. You could either use sine or cosine to then find the hypotenuse. I'm going to use the Pythagorean Theorem because I like that better. I'm going to square that answer. I'm going to add it to a squared, which is 9, and I'm going to square root that, and I have the grand old answer of 8.77. You can try the next one. Go. Okay, Julie asks, is the final going to be difficult? I don't think it will be difficult for you guys. I think you'll do very well in the final because we're going to allot time to be able to prepare for that final exam. Here's the struggle, you guys. Here's the challenge. Every time you move forward in math, it requires you to remember what you've done before, right? So that's the tough part, is as you move on, it's like, what stuff do I truly remember? So you're going to get through this course just fine. You're going to do great. The question is how much of it will be committed to memory. And that will depend on the practice. The final exam should help in that process. It should... 2 hours? I don't know, whatever it takes 2 hours worth. So... Okay, let's check our answers here, people. A should be 43 degrees, B should be 47 degrees, C should be 90 degrees. C is 5.3. What'd you come up with, A and B? 3.88. 3.61. Click the switch, sorry. Okay, let's move on. You won't do that in calculus. We won't be solving right triangles. That's again a review for your ACT and just recognizing the connection. You will do this, okay? Do you remember how to identify the period of different types of trigonometric functions? The period is 2 pi divided by b. 2 pi divided by b. That's for sine, secant, cosecant, and cosine. But for tangent and cotangent, the period is pi divided by b. So we take 2 pi and we divide it by 4. And you get half a pi or pi over 2. That might be how you write it. So that means instead of repeating itself every 360 degrees, it's going to repeat itself every 90 degrees, okay? So you can see 4 times. It's actually a horizontal shrink is what's happening here, okay? This one's going to be pi divided by 1/5, which is 5 pi. This is pi divided by pi, which is 1. Or I'm sorry, 2 pi divided by pi, which is 2. Secant and cosecant is 2 pi divided by b, just like sine and cosine was. It's when you get tangent and cotangent that's just pi. And if you want that sheet of notes, if you look in your little handy-dandy thing here, all the way on the back side, this sheet right here tells you all the characteristics that you need to know about sine, cosine, their periods, their shifts, everything else. That's all right there for you. What's your b value here? 1. 2 pi divided by 1 is 2 pi. So that only has a horizontal shift, that's it. Can you sketch these? There are times in calculus where you do want to come up with the sketch because often we're finding tangent lines to functions, and so you want to have an idea what it looks like. So what's the amplitude of this one? How much does it go up and down? Very good. 3. The period. Pi. Horizontal shift. Nothing. Vertical shift. None. So if you remember how often sine repeats itself over the course of 4 quadrants generally. So I divide it up into how many parts? 4 parts. But this time it repeats itself every pi, so I'll take that pi, put it there as opposed to 2 pi, and I'll now divide it into 4 equal parts. My amplitude, up 3 and down 3. The sine start at the min, the max, or at 0. Starts at 0. Because the sine of 0 is 0. Does it start by going up or going down? Up. You got to appreciate, you guys, how much time last year we took talking about the first 2 pages of this review. And we've gone over it now in a half an hour. I want you to do the last one. We'll end on that. See if you can do this one. Okay. Okay, that's what your graph should look like. Number 1, why is the amplitude not a -1? Yeah, the amplitude is always positive. It's the absolute value. Okay. Second of all, the period should be 8 pi because you divide it by 2 pi divided by 1/4 is 8 pi. I divide up into 4 congruent parts. There's no horizontal vertical shifts. Cosine starts at either the min or the max. Why does it start the min in this situation? There's a negative in front, so it starts down -1. It heads up. There's your graph. We return on Monday. We will pick up with these 2 graphs, and then we will be doing most of what you'll see in pre-calc, which is some of this stuff. Okay? And I'm going to stop my video.